Picture waves curling on the ocean, but they're made of plasma, and the ocean is the sun. That's one of the images that stuck with me this week. Hello and welcome. This is episode 5 of our weekly science show, looking at the science of the week for August 11.
And we've got a good mix. A powerful solar telescope catching textbook physics on the sun, a space mission giving us a fresh look at a human-made scar on the moon, and a quiet engineering move that keeps a legendary spacecraft talking.
Plus a sky show that wants to dazzle midweek, even if clouds try to photobomb it. And a big, very early universe puzzle with those little red dots. But I want to begin with a story that's as much about people as it is about nature. The Ojai Raptor Center announced that Jackie, the bald eagle so many of us watched on the Big Bear Eagle Nest cam, has died after weeks of intensive care. According to local reporting, Jackie had lived at the Big Bear Nest for at least 15 years and became a real online presence, drawing viewers to those live streams.
According to ABC7 Los Angeles, yes, this is a case where the facts are straightforward and sad. A long-lived, widely watched eagle, and an outcome the rehabbers couldn't reverse, despite intensive care. No speculation from us on causes or anything beyond what's said.
It's a reminder of why those cameras matter to people. When you watch a nest in real time, you feel connected to a life that's both routine and epic. And when you lose that, it stings.
And the science angle here is modest, but real. Those streams draw attention, which can translate into support for conservation and rehabilitation groups. The report makes clear Jackie drew viewers. That's a signal of public engagement, even though we're not assigning numbers or outcomes.
To everyone who kept vigil and sent good thoughts, take care. Nature gives us wonder, and sometimes heartbreak, and both are part of paying attention. From one kind of skywatching to another, the Perseid meteor shower is set to peak on August 12th and 13th. SF Gate reports that cloud cover and fog in the Bay Area may limit visibility, and organizers are even putting together indoor watch parties and online streaming.
It's a nice example of adapting to conditions. If the atmosphere won't cooperate, bring the meteors to a screen. The report also notes earlier coverage that the new moon will provide dark skies this year. That usually improves visibility if you're under clear skies.
There's something poetic about a shower that politely schedules itself, then leaves us negotiating with the weather. If you're not in the Bay Area, maybe the clouds will cut you a break. If you are, at least there are ways to join in without freezing on a foggy hillside.
And since this is a news item, a quick grounding. The timing is clear, the local cloud forecast is the limiting factor, and the streaming option is a practical response. No hype needed, just a heads up to plan accordingly.
Now let's jump outward, back to the moon. We covered this story last week, but there's a fresh angle. South Korea's Danuri spacecraft has photographed the new crater and a darkened patch from a SpaceX Falcon 9 upper stage impact.
Right, this is a follow-up. Previously, we talked about the impact event. The new information is that Danuri captured images of the fresh crater and darkened area, and mission officials said they'll carry out further observations. NASA reported the 4-ton second stage hit at roughly 5,400 miles per hour.
That speed is eye-widening. And the fact we can return to the site with a lunar orbiter and see the mark, not just infer it, feels like healthy science. You check, you confirm, you study.
Exactly. It's documentation, not drama. The additional observations matter. They can help characterize the darkened patch, how the material spread, and so on. We're not adding details that aren't in the report, but the direction of travel is clear. Observe, analyze, repeat.
And it's another nudge to think about how we care for places we visit, even airless ones, and how we learn from the footprints we leave. Speaking of observations that make your inner physics nerd hum, the Inouye solar telescope captured Kelvin-Helmholtz instability vortices on the sun's surface. Imagine wind shearing over water and you get rolling wave crests. Only here, it's plasma and magnetic fields dancing.
Kelvin-Helmholtz is a classic fluid instability. When two layers move at different speeds, you can get those characteristic billowing curls. Seeing them on the sun is notable because it ties visible dynamics to the magnetic activity that drives solar flares and coronal mass ejections.
And we've talked before about the telescope's record-breaking resolution of the sun's outer layer. This is the payoff. It's not just pretty pictures, it's physics you can point to.
To stay rigorous, the report states that capturing these vortices provides new insight into the magnetic activity behind flares and ejections. That's a reasonable claim. It's not saying we've solved space weather. It's saying we can now watch a key instability directly in action, which strengthens models.
And it's a reminder that even the familiar star over our heads hides oceans of complexity. The sun is not a tranquil yellow ball. It's a roiling magnetic beast with wave crests as tall as, well, we're not guessing sizes today, but enough to humble you.
A safe choice. The important bit is that this is observation at high fidelity, revealing fundamental processes. That's science in its most satisfying mode.
Another quiet win this week. NASA engineers at the Jet Propulsion Laboratory in Pasadena successfully performed a power-saving maneuver on Voyager 2. The goal? Extend the life of its remaining instruments. And they're planning a repeat on Voyager 1.
This is engineering stewardship. The report says the maneuver was successful and extends instrument life. It also notes the plan to apply it to the twin spacecraft. Earlier, the agency had described the new sequence as a way to keep Voyager 2's instruments operating longer.
There's a kind of gentle heroism in that. Decades on, with power dwindling, a few careful choices buy more time for a machine that keeps whispering from far away.
From a rigor perspective, we're not adding projections beyond the report. It's enough to note the success and the intention to repeat. The larger picture is that small tweaks can have outsized value when you're very constrained.
And it's a good lesson in how exploration continues. Not with fireworks every week, but with patient, clever nudges that keep the door open a little longer. Now for the big, puzzling tale from the early universe. Astronomers at the Harvard-Smithsonian Center for Astrophysics reported that James Webb Space Telescope data have revealed more than 300 infrared sources that could be ultramassive stars, up to 100,000 times the sun's mass, offering a possible explanation for the enigmatic little red dots.
Two key words there: could be. The report frames this as a possible explanation. The number is specific, more than 300 infrared sources, and the proposed masses are extraordinary. Extraordinary claims require strong evidence, and the language here properly hedges.
The little red dots have been a head-scratcher. Compact, bright, red in infrared, and not easily filed under the usual categories. So the idea that some might be titanic, short-lived stars rather than, say, galaxies would be a shift.
And it's appropriate to keep this provisional. What's on the record is that these sources were identified in JWST data and could be ultramassive stars at that scale. That's a hypothesis drawn from the observations. Confirmation would need further study. The good news is that we have the telescope to pursue it.
I love that this is the same week we're talking about vortices on the sun. At one end, fluid curls on our star. At the other, potential stellar monsters from the dawn of time. It's all part of the same effort. Look closely and let the data nudge your theory.
And remember, more than 300 is the sample size as reported. That's a lot of candidates, which is encouraging for testing ideas. But even a large pool of candidates doesn't turn a could be into is without the next steps.
We'll keep an eye on it, carefully. Let's zoom back to our own backyard and a story we mentioned earlier about the upcoming Perseids. SF Gates' note about indoor watch parties and streaming stuck with me. Even when the sky is moody, people still find ways to gather for a meteor shower.
It mirrors something we see across this week's stories: observation as a communal act. A lunar orbiter returning to image a new crater. A solar telescope catching a fluid instability. A space agency quietly optimizing a spacecraft so it can keep sending data. People huddled indoors, watching sky cameras if clouds win.
And the hard news beats in there? The follow-up images from Danuri, the cautious framing around those possible ultra-massive stars, underline how science moves. It's iterative. You return to a question with a better instrument or a cleaner hypothesis, and you see if it holds.
And you separate what's established from what's proposed. Established, Danuri saw a fresh crater and a darkened patch from the Falcon 9 upper stage impact. Further observations are planned. Established, the Inouye telescope captured Kelvin-Helmholtz vortices, which inform our understanding of solar activity. Established, the Voyager 2 maneuver worked, with plans to repeat it for Voyager 1. Proposed, those more than 300 infrared sources could be ultramassive stars. That's the right division for now.
I like when you draft the status board out loud, Daniel. It makes my curiosity behave itself.
That's the goal. Not to dampen curiosity, just to give it a decent pair of hiking boots.
And a weather check for the Bay Area.
Always.
Before we close, a quick circle back to the moon story we followed up on. It's heartening to see coordination. NASA reporting the impact speed and mass, Danuri delivering images, and mission teams planning more passes. That's how we turn events into knowledge.
And back on Earth, with the loss of Jackie, there's a quieter form of knowledge, the kind you get from bearing witness. The reporting made clear how many people watched that nest. It's not a data set we're parsing here. It's a community, and that matters too.
If a theme runs through all of this week's science, it's that attention pays off. Whether you're holding a telescope steady on a solar ripple, lining up a spacecraft maneuver, or watching a nest cam long after midnight.
And as always, paying attention includes reading the fine print. What's confirmed, what's pending, and what's possible.
If you want more of that kind of careful, calm science news, come find us at faxlane.com. You can also get the app on the App Store or Google Play. And if your curiosity ranges beyond science, check out our other weekly shows. Good Week for a sanity-restoring roundup, and Tech Week if you like your circuits with context.
Thanks for spending part of your week with us. We'll be back with another round of measured wonder. Until then, clear skies if you can get them, and streaming links if you can't.
Stay curious, take good care, and we'll see you next week.